Yeah, hi everyone. So I'm trying to start this series on RAG, Retrieval Augmented Generation, and I want to start with what is RAG and why is it even needed, and I'll also try to cover what are the topics I'm going to discuss about in the next few videos. And you might ask, how is this video or this playlist different from the other ones that are already available on YouTube? So I'll try to be talking in a layman language, and so that everyone will be able to understand, and you will be able to quickly explain in the interviews as well. So that's the main focus here, and I'll keep interviews in mind whenever I'm trying to discuss the topics. uh, yeah, and I'll not go deep into formulas or AI tech stack, or use all the latest buzzwords in the RAG. I'll try to be talking in a layman language again. Yeah. So we already have LLMs, right? Why do we need RAG in the first place? So if you have a query and if you give it to an LLM, it gives a response. But if the query is not general, and if it is specific, like what is the average salary at YouTube? So this information is available only on YouTube, only with the YouTube HRs or YouTube recruiters or such, right? So LLM will be able to answer based on the available information on internet, but it will not be able to answer based on the company's data. So what are the options available at company's hand? So they can retrain an LLM for this use case itself, right? So that would take up a lot of cost and a lot of computation power, right? It will eat up a lot of time as well. But what if, but they'll be able to achieve what they want. But what if the data changes in 2027, right? They need to retrain again. In 2028 they need to retrain again. So this is not an option in such cases, right? So what about fine tuning model? So they same things come. If the data changes, then they need to do it again. So we definitely have very efficient methods like LoRa, or LoRa or QLoRa, etc., PEF methods, in order to do fine tuning at a lower cost. But we need to repeat it again and again. But if the data changes in somewhere, say quarter 2 of 2027 to 28 financial year, so then we need to update, do the fine tuning again, right? So that's not affordable for us. So that's the reason we have RAG. So how does RAG work? A RAG is formed by three words: retrieval, augmented, okay, just a minute, augmented and generation. So let me talk about each of these. Okay, so first thing, so what we'll do, we will have those, where will have the docs. These docs we need to have as an external knowledge base. Okay, in a vector database, which I'll cover what is a vector database in the later videos. But we'll have them as external knowledge base. Okay, and whenever we ask a query, so from these external knowledge base, a context is retrieved. Context as in, let's say there are two pages in the document of YouTube salaries data with HR. Okay, so it will pull out maybe the first paragraph that talks about the average salary at YouTube, and it will add these paragraphs to the query. So earlier we have only query, right? Now we have query plus the context. We have both of these. So these two will be given to LLM. So LLM, what was it doing earlier? It was just taking the query, and based on the knowledge of the internet that it has, that it was trained before, it was giving a response. Now it will use the knowledge that it has knowledge about all of the internet, and how to form a sentence, grammatical knowledge, etc., right? So with that, it will also have the context at hand. So this is a query, this is a context. Now it will give a response based on the context already available. Okay, so how will it retrieve? This is the augmentation part. Augmentation is nothing but adding the context to query. And retrieval, so the question is retrieval. When we talk about R of the RAG, okay, from where? So where will it retrieve from? How will it retrieve from? And how much of the context will it retrieve? So these are the topics that we'll be covering when we talk about RAG in the future. Okay, so from where, I'll just tell briefly. From where? From the vector databases. There are a lot of vector databases. And how will we retrieve? Using methods like ANN, approximate nearest neighbor search. So we can also do a KNN. We can take the query, find if we have say thousand vectors or thousand contexts in the layman language we say, so we can compare each of the thousand contexts or chunks available with the query and then retrieve, right? So that will be how many thousand times we need to compare. We need to compare thousand times, but we have something called, this is KNN. But if you want to do it more efficiently, we have what is known as ANN, approximate nearest neighbor search. So there are few techniques in that as well. And how much of the context is to be retrieved? So if we have a say 100-page document about the salaries at YouTube, so we cannot retrieve maybe 50 pages. That will be a lot of context, right? LLMs have a set context window or a token limit, so they'll add up to cost. So we need to take that in mind, and how much to be retrieved, we'll decide on that, and what are the ranking methods in order to retrieve and in order to augment in order to get the context and put it there, right? If the context is too huge, what we'll do, we'll use summarization techniques or context compression techniques, which I'll be talking about later. And in that way we will be able to handle RAG, and we'll be able to do it end to end. And regarding like, this is the main gist of what is RAG in a layman language. But what will be asked in interviews, that will be your main question, right? In interviews, so the questions will not range from what kind of they'll not ask you to views, okay. Okay, yes, they'll not ask you to design a RAG program, or they'll not straight away ask you to explain the architecture or etc., right? They'll ask you concepts. What happens if the retrieve context is of 50 pages and is of say 500 tokens, and the context limit of LLM is just 200 tokens? How would you handle that? So how would you handle a question, say if someone asks something like this? This is the only question that query user is asking. User doesn't know he will not follow what we are saying, right? He'll not follow if we say him to write the queries in proper grammatically correct English sentences. He won't do so. We cannot expect that behavior from them. So he might ask something like this, so we need to form it something like this, a proper grammatical structure for LLM to understand. So this is not a complete word in the first place, right? So this is known as we need to transform the query transformation techniques. So I'll maybe talk about what are the topics that I'll be covering going forward, and then we can we can talk about each of them in the upcoming videos. So I told you, right, we have embedding. What is embedding? So we have the text in we have the query in form of a text. We need to convert it into numbers for the LLM to handle it. In LLM, what do? We just do matrix operations, right? So we need to have numbers. So these are some of the embedding models. I'll talk about what are dense and sparse embedding models, and going forward, what are the techniques in order to convert the given text into embedding. Like in machine learning, we have TF-IDF or count vectorizer, right? We have something similar here. We'll talk about those, and I just talked about this, right? If a query is ambiguous, as in if someone says something like this, half sentences or just vague queries, we need to rewrite the queries, we need to expand, and there's something interesting called as HIDE, hypothetical document embeddings. We'll talk about that as well. And we'll talk about chunking, which is dividing the whole text into different parts. And there might be some queries where it will have multiple questions in a single query, like say who is the CEO of the recent startup acquired by Reddit. If the query is something like this, so we first need to find what is the startup acquired by Reddit and then its CEO. This is a multi-hop query. It requires 2 steps to be done, right? So we'll talk about these. And apart from this, we have vector database, which is where we store all the data, all the external database, right? So we'll talk about what kind of vector databases are available. I'll try to not go into detail, and I'll leave it for you to explore this. And I told about ANN, right? Approximate nearest neighbor search, instead of using KNN, which is a crude method, or which is a time consuming method, right? And we can retrieve based on keywords as well. So if the document is on medical terms or a law based document, or keyword heavy document, then we need to search for the keywords directly, and then we can do the retrieve the context. But if it is not keywords, and there might be synonyms available, or we might not find the exact information or exact words, then we'll go for a hybrid or a semantic vector search, and sometimes we need both of them. So in that case we'll go for hybrid. And I'll talk about filtering on metadata. Some documents may be numbered, and they might be domain specific. Suppose there are four or five departments at YouTube, let's say revenue, finance, sales, etc. And all of the like for one query, what is the average salary at sales department? So we don't need to retrieve all of the documents, right? We can have filtering based on the metadata available, only based on those kind of documents, those documents that are relevant to sales department, right? And apart from this, we'll talk about what is index and why index is required. Okay. And I talked about context augmentation, right? With the query we need to add some context. So how do we add it? So how many chunks to retrieve, or how much of the data to be added? And even after retrieving say top 3, we'll have 1 2 3 chunks retrieved for them to be augmented, right? After that we need to rank them as well. Sometimes they may not be accurate, or all of them might be similar, all of them are conveying the same information. So when they are conveying the same information, the correlation is 1 between them, so we might not need all of them, we can need only some of them, right? So we'll check about what is re-ranking. And I said about LLM having a set context limit, right? In that case we'll need to use context compression. And these are some other topics like context window management. Yeah, we talked about token limits already, and prompt construction. So these are some of the topics. There are five subtopics in total. So this is the fourth one here, LLM generation. So after the augmentation part, after the retrieval part, we augment it, and then we give the query and the context to LLM, and it gives an answer. So what are the various prompting techniques that needs to be followed? Which kind of LLM should we use, and what are the post-processing techniques that we need to follow, and guardrails. These are very important. These are often ignored, and these are asked in the interviews as well. Like if someone asks a query like how to commit a suicide, what are the weapons that I can use? So these are the kind of questions that should not be answered at any cost, right? Those are harmful. So if our LLM or a RAG system is answering such questions, then we failed at building a good RAG system or an LLM service. So how do we handle such queries? And caching, I'll come back to this is a very important topic, so as to not have too many LLM calls done, right? If the similar queries are asked again and again, we can just go back to the answers that are provided previously. And grounded or up-to-date answer, this is a very important topic in RAG. So we already have the documents, so our LLM should answer only from those documents and not from elsewhere, or it should not make up any kind of new answers, right? So it should stay grounded as in answer only from the context that is available. So how do we ensure that? We need to let's talk about this in the coming videos. And freshness and updates. Okay, so I talked about data changing from 2027 to 28, right? So when that happens, so we need to update our vector database as well, that we already have, right? If we don't update it, then there's no point of using RAG. We can just use any other method. So let's talk about that. And when we are building such a robust thing like RAG, we need to have some kind of mechanism to assess its performance, as in how good is it performing or not, right? So there are some metrics which can be used in order to assess its performance, and some evaluation frameworks as well. And at the end of it, our RAG system or our RAG service or our RAG application should go into production. So what are the kind of monitoring correctness or hallucinations that we might see, and how do we optimize latency and cost, and what are the real-time retrieval integration methods? So we'll be talking about all this. So we'll be talking about the query embeddings. This is one subtopic. We'll be talking about vector database retrieval. We'll be talking about context augmentation. We'll be talking about LLM generation. We'll be talking about grounded and up-to-date answers. So these are the 5 subtopics that I'm thinking to cover. And I mean, for most of the interviews, for most of the interview question based on RAG, these will be more than sufficient. Yeah, I mean, these are exhaustive, and you might not find any other question in the interviews apart from these. And there are some of the advanced topics, like there's a recent page that I've read about page index, which eliminates the need for vector database as a whole, right? Yeah, after these basic ones are done, we'll talk about page index, and maybe in future we'll go to agents as well. When we have RAG already, why do we need agents? And and in interviews, you will not be expecting, even if you go for core AI engineer interviews, you will not be expecting questions only on RAG and agents. You will be asked questions on stats, core statistics, and machine learning as well. So I'll try to cover those in interview point of view. And yeah, let's see how this video lectures go. Yeah, thank you, that's it for today. And please let me know if you have any questions or if you have any suggestions as to how I can proceed with this. Thank you, have a nice day, bye.